Hi, everyone. I'm excited to be here. I've been in Prefect for the last year and a half. I've given this talk in like over, a couple times already, but this is actually my first time giving this talk in person. So very happy to be here. So about me, my official title is I'm an open source community engineer at Prefect. Uh, I'll go over what Prefect does in a bit. But basically, as a community engineer, I help our users, open source users, adopt Prefect. So primarily, through Slack or making content or going to meetups and conferences like this. Outside the Prefect, I contribute to another open source project called Fugue. Fugue had a session yesterday also in the data lifecycle track, and I also organized the Orlando Machine Learning Meetup. So for today, we're just going to go over what general workflow orchestration is, the use cases, a bit of history about Prefect, and then we're going to talk about why Prefect explicitly moved to the 2.0 and what exactly is different about 2.0, and then we'll use Prefect and build a simple workflow. So, what is workflow orchestration? Workflow orchestration is pretty self-explanatory for the most part. I think a lot of you will already have an intuition for what workflow orchestration means. Even my mom told me actually, I know what workflow orchestration is. Oracle does that, right? But workflow orchestration is basically you have a couple of processes that you want to run in some kind of order, and you want to schedule and monitor the running of those processes. So that can be like data pipeline, or it can just be a bunch of stitched together Python scripts. But I think to put it more concretely, we can take a look at a sample pipeline here, where we have this machine learning pipeline, and this machine learning pipeline takes in data from the left side. There's a database, there's an API call. We combine it in a pandas data frame, do some machine learning. And during that machine learning process, maybe we output some artifacts of our experiment to MLflow. And maybe if the model is good enough, we deploy it to Flask. And if we look at this pipeline, there's many places it could fail. What happens if the API calls fail, which can happen intermittently? What happens if the database goes down? Maybe it's being used too much. There's too many concurrent connections. What happens if data comes in malformed? Or what happens if let's say our model training just fails, didn't converge or something like that. MLflow is also an API. It's also a point of failure. And the other, and when we see the surface area of the possible failures here, there's both things that we know it can fail in that way, and there's also things we don't, this pipeline can also fail in ways that we don't expect or we don't know ahead of time. And as an engineer, you can make this more robust by coding your own things. Like, for example, can you make your own retries on the API? Or, for example, can you have checks to see if the data is malformed ahead of time? But when you write this defensive code, that's what we refer to as negative engineering in Prefect. So when we talk about negative engineering, well, to distinguish, let's talk about positive engineering. And positive engineering is the things you do in order to achieve the business outcomes that you set out to achieve to begin with, that you're actually working on. You want to actually predict if a customer is leaving, maybe, or you want to actually predict forecast demand over time. These are the things that you are actually an expert on and you're trying to do. And negative engineering is the collection of those things that these defensive engineering things that you need to do in order to make sure that your positive engineering continues to run smoothly. So, for example, you can how do you restart from failure? How do you code retries? How do you time out if things are taking too long already? And on the scaling side, how do we schedule your workflows? How do we give notifications in the event that things fail? And failing in a general sense, like how do we just generally get notifications? So these are all things you'd have to code on your own, and these are things that are normally addressed or given to you if you use a workflow orchestration framework. So Prefect is an open source workflow orchestration framework. Currently have around 9,200 GitHub stars. Slack community, which I'm responsible for managing, has around 19,000 people now. So we are open source, Python based, and designed to really integrate with the modern data stack. Prefect has a lot of roots integrating with Dask. So the Prefect 1 has a very tightly coupled Dask integration. And we have a very active community. If you just want to chat about workflow orchestration, you would just want to talk about good data engineering practices, we definitely invite you to just come in and throw a question in the Slack channel. It doesn't even have to be fully Prefect related. So the current state of Prefect, there is Prefect 1, which is called Prefect Core, and we actually moved to Prefect 2, which is called Prefect Orion. And the reason, so if I say Orion or Prefect 2.0, it's pretty interchangeable. And the reason we built a 2.0 from the ground up very recently, and when I mean very recently, the 2.0 is in beta right now, and maybe in the next week or two, it will be in general availability, but everyone can already just use it. It's open source. You can just pip install, and I'll demo it. But the reason we made 2.0, and this is maybe a bit more for people who are familiar with workflow orchestration already. Workflow orchestration has traditionally been synonymous with the concept of the DAG, right? The directed acyclic graph. And if you're unfamiliar with what the DAG is, the DAG is basically all your steps and the arrows drawn between them. Like this is already a DAG, and this is basically our workflow graph. And traditionally, in workflow orchestration systems, you had to predefine the workflow graph ahead of time, and you could not deviate from it during runtime. And that led to a bunch of limitations that I'll go over in a bit. But just to show some like what Prefect 1.0 looks like compared to Prefect 2.0, here we have just a simple flow to count the number of GitHub stars for a certain repo. So you can, the main Prefect dependencies here are this task decorator and this flow block here. And the rest looks very Pythonic. So Prefect 1.0 was already very Pythonic in a sense that just by using these, calling these tasks inside the flow block, you get an automatic, number one, passing of data between tasks. Number two, you get an automatic setting of upstream and downstream dependencies, and we can construct that graph from that. And then when you're ready to test it, you just do flow.run. And when you're ready to productionize, you do flow.register. And now Prefect 2.0, we remove that. The task is still the same, task, but we now remove that flow context manager, the with statement, and now it's been replaced by a flow decorator. So now it's more Pythonic than ever. And in order to just run this flow, all you have to do is just call it like a normal Python function. And we will explore what this dynamic DAG-free workflows means, because that's the highlight of this of Prefect 2.0. So there are a couple of things that the DAG inherently constrained. Having to predefine your workflows ahead of time introduced a lot of friction for developers with newer data use cases. For example, you couldn't add tasks during runtime based on a certain condition. If you had some kind of sequence like ABC, and if C did not meet the condition and you wanted to go back and rerun ABC again until it met the condition, this broke the acyclic nature of the DAG, so you couldn't do stuff like that. So we decided the DAG actually introduced more friction than benefit, and we removed it. And with that, we'll start with a simple problem here. So, okay, I have a Python script here, but I'll open this this page first so you guys can see what we're going to do. So here we have a Nike shoe that we are concerned about. I don't know if you can see this. This here is a price, and this price actually changes regularly. So we want to build a simple script that will go in, get the price every day, and if the price is below some certain our budget, then we want to buy the shoe, and we want to get notified to buy the shoe. Right, so I have a simple script here already that does a bunch of groundwork for us. So number one, we open the website. Number two, we compare the price against our budget. No, and then number three, we just called the previous two functions. So number one, we get the price given the URL. And number two, we compare the price and see if it's within our budget. So this already works. And I can simply just call this file Python shoeprice.py. And you should see something like, oh, don't buy the shoes, they're too expensive. Okay, so how would we go about bringing this in Prefect? And here's the really cool part about 2.0. In order to bring this to Prefect, all we have to do is import flow. And we just want to use the flow decorator here. And this already brings it into Prefect. So if I run this script again, this is the actual calling of the flow. I didn't change anything else, you're going to see that there's something different. There was a bunch of observability added around our flow run. So here we created the flow run, and you should just see, oh, the flow run completed. So that's pretty much it. And what's nice about Prefect 2.0 is that it's very, now what I'm gonna do is under the hood, this has been running against a data, like a SQLite database, and we keep track of the history of your flow runs. So if I do Prefect Orion start, again, Orion is the name of 2.0. I'm spinning up a server now, and we're gonna navigate to this page. This is the UI for our flow runs. You're gonna see there are some flow runs I was running earlier when testing. The specific one that you should be looking for is this Elite Caribou that was created, and that's this one over here, right? So now we get a history of our flow runs. We get the duration of them, and we can go inside, but we're not gonna see a lot of logs. And the reason for that is because we just had a flow with that didn't have any explicit task. So tasks are the unit that add observability to our Python functions. So again, if I go back here, first of all, I'm going to stop this Orion instance just because it gets annoying running Python, then opening this. So I'm going to use another terminal for this. And we're going to leave our server on. But if you noticed, I didn't even need the server on to run, because we have like an ephemeral API that gets spun up, runs against the database, keeps the state of things. You don't need the server up to run stuff. You just need it to view stuff. So going back, we have our flow, and I will import task, and then we can decorate this, and now we are using both tasks inside the flow. What I'm gonna do is I'm gonna run the script again. And you're gonna see that you kind of get more logs because each of these tasks are now being individually tracked. So this is the compare price task, and this is the find Nike price task. So now by opting in to the task, you get more observability into those Python calls. But what other benefits do you get from using this task decorator? Well, I could do something like this, right? Retries equals to 3. And this will now retry 3 times. Again, API calls could fail. The website could be down. I could add the retry delay as well, but I won't, just to keep things simple. So here I'm saying I want 3 retries on this. And in order to show you that the retries do work, I'm just going to raise an error right here, just so this thing will try to retry 3 times. And in the logs, you will see that here's 1 value error. And you should see 2 more pop up. This is 1, and this is the other one. So we saw just by opting into the tasks, and you can add you can easily get retries just by adding retries to the decorator. So again, like this is something that you would have to write a lot of code yourself in order to implement. But now, just by using a workflow orchestration framework, you can get that very easily for free. And then the next thing we're going to do is, you see this this task over here. For a given price and a given budget, the result will actually be the same. So what we can do here is we can put a cache on this task, so that if Prefect sees that the same inputs are coming in, we don't need to rerun everything, and we can just load the result from the actual cache. So what I'm going to do I'm just gonna copy some code here real quickly and stick it here. So I'll move this up just to clean things up. Oops. Okay. So now we have our cache key function, and this is saying we'll hash the inputs, and we'll compare them across previous succeeding executions of this task across different flow runs, and then this cache will expire for a day. So in order to demo this, I'm going to rerun this once, and the first time I rerun it, you're going to see that it did, of course, run that. There's this print statement here, But I'm going to run it again, and you should see that the cache is now respected because the budget and price didn't change. So here you're going to see that that log is now missing, and you're going to see something here where it says it's already cached. So it just pulls from the cache now. So again, just by adding a few lines of code, you can also add caching capabilities to your flow. I'm going to remove this now. And the last thing I want, I mean not last thing, but another feature that I want to talk about is you see that these tasks are basically just Python code, and one of the beautiful things about that is now anyone can just write their own Python code and make it a generic task that other people could use. So we have a task library. We called it task library in Prefect 1. It's now called the collections catalog in Prefect 2. So if you have, very cookie cutter kind of task that you want to run, and it already exists in the collections catalog, what you can do is you can just use the given task, and then it should allow you to do things very easily. So a lot of very common very common patterns are like using like SQL or like dbt, Snowflake, like these kinds of data tools. I'm going to use the Prefect Slack task specifically for this demo. And I want to give myself a message when the price is low enough for the shoe. So in order to do that, I'm just going to make a couple changes first. First of all, here I'm going to just return true instead. And here I'm going to return false, just so I can do something with that. And in Prefect 2.0, something that was really hard to do in 1.0 is that in your flow, it's a bit magical, but it becomes hard. Like, how do I actually check if this value is true or this value is false? In Prefect 2.0, these are it's as if it were like an asynchronous function. So what you can just do is you can call .result here, and now we can use the native Python if and say if this is true. We can do the print statement instead. And this paradigm was not possible in 1.0 because in 1.0 you always had this like DAG kind of concept. Everything had to be like deferred execution. So now in Prefect 2.0, because we don't have that DAG concept and everything is deferred by default, you can use the native Python if. You can use the native Python for loop or while loop. And then you can check your conditions. So this definitely extends the possibilities that you can do with workflow orchestration. So we should be able to just run this. And I think I won't get the message because my budget's 150 and the price was 160 today. The price really went up, like compared to my previous demos. Okay, so. I'll just make this 200 so we get something, because I'll need to see it on Slack also later. Okay, so we see this buy the shoes. So now I want to actually use the Slack collection and send myself a message. So I made a webhook for Slack using the Prefect app, and now I can use this webhook. I can go to the documentation for that given collection, and I can just easily copy this, and it says that this is how you would send a webhook to yourself. So I already did that, and what I'm gonna do is I have it already here in Scratch. So I'm gonna import these. These are the guys from our documentation. Sorry. Okay. And if everything works well, I should get the Slack message. This has failed on me before. And I need to get these guys. Oops. Sorry, I'm lost here. Okay. So this is the token that I just generated for this demo. And this is actually, one second, there's a bit of a typo here I need to fix. And then this should be Slack webhook per the docs. So I'm going to change this to webhook. And I'm just going to say something like hello SciPy, just so you see the message. So again, if we compare the price and if we're below budget, it will evaluate to true, and we should see that we get a Slack notification coming to me. So it says it completed. We have this hello SciPy, which just got released, which just I just got message just now. So we were able to, with just a couple lines of code, because these tasks already exist in our task library or collections catalog, I'm able to just leverage them. So this is very useful if you're like loading things from a database or maybe interacting with a lot of common AWS tasks. You can easily use these as a template and stitch together some of these tasks to make common data pipelines. The last thing I'll just mention, but not really dive that deep into, is how do we actually schedule this now, right? So here I've just been running it. Oh, I actually haven't been showing. I just want to show you guys that it has been updating in the UI. I just have, so we've been adding all of these other flow runs in my other executions. Now what I want to do is put this on a schedule. So I'm just gonna copy some code here for that. So the abstraction that Prefect uses to put things on a schedule is the deployment. So here in this script, I'm just gonna comment these out. We don't need them anymore. And now I will put this deployment. And this deployment is telling us, hey, we're going to run this on a schedule I'll make this every 5 minutes. And then we just add some metadata tags. This is the flow object itself. And this flow runner can be replaced to say doc run this in Docker flow runner, or run this on Kubernetes with the Kubernetes flow runner. Here we're saying subprocess, so this is just a normal Python script. And now we can, instead of calling the Python script, we can say prefect deployment create shoe price.py. And we should see that it was able to create a deployment called Nike shoe flow. And if I navigate to the UI, you're gonna see, hopefully, okay, that we have a Nike shoe flow. And this Nike shoe flow is running every 5 minutes as we assigned it. So now if I go to the flow runs, did I attach the schedule? Okay, I think I just, you should see the schedules in the flow runs. If we I don't know what I messed up, but we should oh, here we go. It just took some time. So here are the scheduled flow runs now every 5 minutes for the future. So this is the abstraction, and then I don't have enough time to go over the how we would get these running in a queue and like getting picked up, but that's definitely that would be the next step here. So with that, I'm going to go back to my slides. We went over a simple problem, showed the use case of Prefect. Even for something like a simple hobby project, you may find value in using Prefect. And I just want to talk about the future of Prefect. In the future of Prefect, I did not cover these things in the UI yet, but you may have seen them. These things called blocks. Blocks were just released very recently. Blocks are kind of like you can have connections, for example, to AWS or to Slack or to S3, and you can configure these like secret connections, and these secret connections will be the building block for more powerful applications. Again, Prefect 2.0 is in beta right now, but it's really coming together. General availability will be next week. And then we have a bunch more features such as notifications. So, for example, if a flow fails, notify me in Slack automatically, or send me a text message. So there are a lot more features that are going to be added beyond this. If you need something production ready today, Prefect 1.0 is pretty different from what I demoed, but also still an option. And what I showed you was the open source version, where you can just host, like this is all happening on my local machine. But if you actually wanted Prefect to host, you wanted to use the hosted version of Prefect, and this is totally free right now, you can just go to beta.prefect.io. This will probably change after the general availability. And what you'll see is something pretty similar to what I just showed you in the open source. There's just a bit more features in the cloud version. So if you wanted to use the cloud version, you would just go to Prefect, to this beta.prefect.io. And with that, I'll just leave a couple resources and I'll open the floor for questions. Thank you.
All right, thank you. So we have a few questions in the Slack. If you have others, feel free to add them in there. So first up from Daniel, there was another DAG execution talk yesterday on Flight. What are the differences between Prefect and other orchestrators like Flight, Dagster, and Metaflow?
Yeah, for sure. Number one, I actually got the chance to talk to Savin from Outer Bounds, which is the Metaflow company. So Metaflow specifically, he said that they had the tutorial here in SciPy, and they had Prefect as the more general purpose orchestrator, and then they had Metaflow as the machine learning specific orchestrator. So he really sees them as complements to each other. And Flight that was the demo that was shown yesterday by Niels. Flight uses Kubernetes as the abstraction, so every task runs as an image or in a container. In Prefect, we do have a lot of Kubernetes users, but we also want to make it as incrementally adoptable by any like hobbyist or anyone new to Python. And we do have a lot of people who learn Prefect soon after they learn Python or learn them together, because Prefect is very Pythonic anyway. So we do not require any knowledge of that containers or DevOps. And Dagster is also opinionated in that sense, where Dagster does have some like native like CI/CD. They are opinionated. So I think in the spectrum of things, these guys, you can opt into their system and maybe you get more benefits, whereas Prefect is less opinionated, more general purpose, more flexible and lightweight.
All right, Paul asks, is there an easy way to get a flow/DAG visualization without having to run the whole process?
So that's a very good question, because in 1.0 and with other orchestration frameworks, you register the DAG ahead of time. So you have a static workflow graph already. And but you can just visualize that ahead of time. In 2.0, because we don't have the DAG requirement, it's not something that we have ahead of time. You have a visualization post-run, because there's a lot of tasks that can be added on the fly, so we cannot traverse that graph without executing it.
All right. Megan asks, what approaches can be used to avoid running out of memory for big ETL jobs?
Okay, I think a bit outside workflow orchestration, but I guess like for example, you can use Dask. Dask has that memory spillover to disk. If you're running out of memory, it can like shuffle in and out with your hard disk. But to be honest, that becomes a bottleneck in performance, because of course it's very slow to write. So it's not recommended either. If you're running out of memory, it's either really just breaking it up into smaller jobs, hopefully, and running them in sequence, rather than like running into these resource bottlenecks.
Logan asks, is a DAG-like visualization possible after the initial run?
Yes and no, but because like even if we pinned a visualization to the first run, the dynamicism that we allow, I showed we used in the demo that I had, we used a native Python if statement, and based on the if statement, we had this Slack subflow really send out a message. So even between success other invocations of the flow, you may have a different DAG structure. So it's not necessarily, it won't be the same structure from flow to flow in Prefect 2.0.
Andy asked, how are environments shared in Prefect?
I think this means like Conda environment, or like, that's my interpretation. I mean, he's welcome to clarify, but my interpretation here is like virtual environment. Over here, in the sub-process flow runner, I didn't show this, but you can actually specify virtual env, and this can use a virtual environment also. So and it can use Conda as well. So that's one. But for more like if you are on the spectrum of more like enterprise or like more industry, then you can just use a Docker container, and then here the thing would be Docker flow runner, and you would say image, and it would be your it would be the job of your local execution to be able to pull that image.
All right. Maximilian says or asks, does the API for Kubernetes support things such as mounting volumes or defining environment variables from secrets?
Yes. So when you use Kubernetes, you are going to specify it in your job template. that we Prefect 1.0 had a very like a generous interface where we allowed people to like specify those in the Python code. But what we found was that it kind of became hard to maintain open source wise. So now it's more of just, if you want to do that yourself, we expose the ability for you to add your own job template to Kubernetes, and then you have that flexibility on the job template side, not on the code side.
All right. Paul asked, how does deployment to a cloud provider work?
Okay, so I think the question here is, let's say you want to use AWS, you want to run your flows on AWS, right? So you can spin up an EC2 instance on AWS, or like a Google Cloud VM and compute instance, and then you can just run Prefect on there. You just need anywhere that can run Python and can run Prefect. If you're more advanced, you could use the AWS Kubernetes or Google Kubernetes engine. But then I think in the near future, not yet available, but in the near future, because we had this in 1.0, but it hasn't made its way to 2.0 yet, you're going to see like these serverless containerized execution, like AWS ECS, Google Vertex, like that kind of thing. So for that, it would be whatever your Prefect agent, which I haven't covered, will be the one to kick off those jobs flows as those jobs, like as an ECS task or as a Vertex job run.